Hi everyone, this is VK. Welcome to Smid World. Here I am with another video. Hi, in this video, we will see about heat welding procedure and temperature maintenance in a ball mill tire crack repair, shell crack repair, and kiln tire repair. The ball mill tire or kiln tire is a critical component of a ball mill or kiln, whatever, responsible for supporting the ball mill drum and ensuring smooth rotation. However, due to constant operation, the tire can develop cracks which can lead to equipment failure and production downtime. You'll see here when cracks happen, first we will see the heat affected zone in shell cracks, cause of cracks, analyze the cause of cracks. First one, the thermal stresses from welding or repair, mechanical stresses from operation. Third one, material defects or inconsistency. Fourth one, corrosion or erosion. HAZ characteristics means heat affected zone. First one, altered microstructure, reduced toughness, increased hardness, residual stresses. The consequences of HAZ cracks is equipment failure. Second one, production downtime, safety risk, and costly repairs. Detection methods: visual inspection, radiography, ultrasonic testing, magnetic particle testing, liquid penetrant testing. Repair testings means repair techniques. We can do the weld repair with preheating and post weld heat treatment. Then second point, the overlay welding, third cladding, grinding and machining, fourth replacement of affected section. Prevention measures: the proper welding techniques, preheating and most welded heat treatment, material selection and quality control, regular maintenance and inspection, operating within design parameters. Standards and guidelines: ASME boiler and pressure vessel code, API 650 welder tanks for oil storage, AWS American Welding Standard D1.1 structural welding code, ISO 10855 non-destructive testing codes. Ball mill specific considerations: shell thickness and material, weld joint design and execution, operating conditions, temperature, pressure, vibration. Fourth point is the maintenance and inspection schedules. Here a general overview of a ball mill tire crack repair process. The process will be the same for even any another cracks also. Here you see the first point, inspection and assessment. Inspect the tire for cracks and assess the extent of the damage. UT test, DP test, magnetic particle test. Then the cleaning, clean the area around the crack to remove the dirt, oil and other contaminants. Drilling, drill a hole at the end of the crack to prevent further propagation. Grinding, grind the crack to create V-shaped groove, removing any loose materials. Fifth point, welding. Apply a specialized welding process, example submerged arc welding, to fill the groove. Heat treatment. Perform heat treatment to relieve stresses and prevent further cracking. Fourth point is the machining. Machine the repaired area to restore the original dimensions and surface finish. Testing. Inspect and test the repaired tire to ensure its integrity and fitness for service. The thickness of the ball mill tire can vary, depends on the size and type of the ball mill, even kiln tire also, as well as the material being processed. However, here are some general guidelines on the tire thickness of the ball mill tires. Small ball mills lesser than 2 meters in diameter means 20 to 40 mm thickness will be there. Medium ball mills 2 to 4 meters in diameter, 40 to 60 mm thickness. Large ball mills means 4 to 6 meters in diameter, means 60 to 80 mm thickness. Extra large ball mills over 6 meters in diameter, 80 to 100 mm thickness, or 3.2 to 3.9 inches or more, depends on the capacity. Keep in mind that these are general estimates and the structural thickness of the ball mill tire may vary depending on the specific applications and manufacturer's design. It's also worth noting that the tire thickness may be influenced by factors such as the type of material being processed, mill's rotational speed and loading conditions, the desired lifespan of the tire, the manufacturer's design and safety considerations. If you have any special ball mill in mind, I recommend you consulting the manufacturer's documentation or contacting their support team for more accurate information on the tire thickness. The heat welding procedure and temperature for ball mill tire repair typically involve a combination of preheating, welding and post-heating process. Here are the general outlines. Preheating: heat the tire to uniform temperature up to 190 to 150 degrees centigrade to reduce the thermal shock and improve weld penetration. Then use a heating medium like electric blankets, induction heaters or gas burners. This is preheating procedure. Then while welding, use a suitable welding process. Example: submerged arc welding, shielded metal arc welding with a nickel based or high chrome electrode. Maintain an interpass temperature 90 to 200 degrees centigrade to prevent overheating. Apply multiple passes, allowing each pass to cool slightly before applying the next. Post-heating: heat the repaired area 300 degree to 425 degree to relieve residual stresses. Hold the temperature for 1 to 2 hours, depending on the tire size and material. Slowly cool the tire to prevent thermal shock. And temperature control: monitor temperatures using thermocouples or infrared barometers. Maintain a consistent temperature throughout the process. The important notes: consult the manufacturer's guidelines for a specific temperature requirement. Ensure proper ventilation and safety measures when working with heat and welding processes. Consider hiring a professional with experience in ball mill tire repair to complex or large repairs. Remember, this is a general outline and specific temperature requirements may vary depending on the ball mill manufacturer and tire material and local regulations. Welding electrodes: for ball mill tire welding typically require specialized electrodes that can stand the high stresses and abrasive environment of the ball mill. Here are some common welding electrodes used for ball mill tire welding. Hard facing electrodes: these electrodes deposit a hard wear resistance layer to extend the life of the tire. Example: EFE8 and EFE10. High chrome electrodes: these electrodes contain high levels of chromium, example 25 to 30%, for excellent wear resistance and high temperature properties. Examples: electrode number ECRMO1 and ECRMO2. The tungsten carbide electrodes: these electrodes deposit a tungsten carbide layer for extreme wear resistance. Example: EWC1 and EWC2. Nickel based electrodes: these electrodes offer excellent impact resistance and are suitable for welding cracks in ball mill tires. Example: ENI chrome Fe2 and ENI chrome Fe3. Please note that the specific electrode selection will depend on the ball mill manufacturer's recommendations, the tire material and the local welding procedures. It's essential to consult the manufacturer guidelines or engage a professional welder with experience in ball mill tire welding. The 2222 and 9018 electrodes are both used for welding, but they have different characteristics and applications. See the 2222 electrode. This one is a nickel based electrode. High strength and toughness, excellent resistance to corrosion, high temperature oxidation, good ductility and impact resistance. Typically used for welding nickel based alloys, stainless steels and dissimilar metals. The common applications like aerospace, power generation, chemical processing and cryogenic services. If you see, go for 9018 electrode. This one is iron based electrode with a high chromium content, that is 8 to 10%. Hard facing electrode for wear resistant applications. High hardness and abrasive resistance. Good impact resistance and toughness. Typically used for welding and repairing equipment. Subjected to heavy wear such as ball mill tires, crusher parts, and excavator tape. Key differences are this one double is nickel based and 9018 is iron based one. Chromium content lower in 2222 and higher in 9018. Hardness is double is a little bit softer than 9018. Applications different industries and purposes. Use the double electrode for high temperature and corrosion resistant applications, welding nickel based alloys and stainless steels. Use 9018 electrode for wear resistance and hard facing applications, building and repairing equipment subject to heavy wear.